All right, welcome everyone. This is David McKay. I'm the course coordinator for SCI 105 Chemistry. This little video is just basically giving you some introductory information about the course so you are, one hopes, more successful in your studies. Okay, so first point I'm making here is probably the most important one of the lot. At the end of the day, all of the information for this course, and indeed I would guess every other course that I'm aware of anyway at USC, all that information is in Blackboard. You can't just rely on information that's given in lectures and tutorials. Everything is written down in Blackboard, and in fact there's additional information in Blackboard that you may indeed need. So I've written there, Blackboard is the learning management system. That's the generic term for this idea of having a computer program, if you like, that you can generally access to get all your course information. So the LMS for this university is Blackboard. There's other LMSs as well, just if you're wondering and you're talking to one of your colleagues from another university. They may use something like Moodle, for example. So please, I encourage you to make sure that one of your first ports of call is actually Blackboard itself. Now, when you do go into Blackboard, rather than just randomly looking through everything, what I've tried to do is actually encourage you to systematically go through the information for the course. So first place to start is actually in the welcome announcement that's posted in this course, and it actually says in the welcome announcement, please then go into getting started. Now, getting started is actually in the course menu. The course menu is on the left-hand side of the screen that you're looking at, and it actually just simply says in that course menu there's a whole bunch of different things, one of which is getting started. Now, if you click on getting started and you go in there, you will see, again, quite a bit of information. So how do you actually know where to systematically start looking through things? Well, the answer is I've actually put a checklist in for you. So if you get that checklist and you download it, you can either use it directly on your phone or whatever, or you can print it out. And I would suggest that you then use that checklist to go through and double check that you understand what's going on in the course. We will actually also do that in the first tutorial. Okay, well, I've actually just said the same thing there, so we won't worry about that. Now, that getting started quiz is actually designed to double check that you've indeed gone through everything systematically. The quiz is simply a formative one. There's no marks associated with it. Formative means there's no marks. And the idea is that we want you to double check that you know what's actually in the course and what's required of you. And it is absolutely crucial. Look, this will take you some time to do, but the fact of the matter is, if you don't do it, you're going to end up spending more time later because you haven't done something correctly, for example, right? You've missed something that's of absolute importance. So please, again, I can't stress enough, make sure you tackle that getting started checklist and then do the quiz as well, just to double check you know what's happening in the course. Okay, now I'm just going to talk a little bit about SCI 105 and just a little bit about the course so you know where we're headed with this course. So I know for many students SCI 105 chemistry is actually compulsory, right? And you're probably wondering why it's compulsory. Well, it's basically because most courses need some understanding of chemistry for you to be able to then understand what's happening in those other courses. In other words, SCI 105 is an enabling course. It's helping you study for other courses. So Because there's no real prerequisites for entry into many of the programs, then SCI 105 can't be anything other than an introductory chemistry course. So there are, from my standpoint of designing the course, there are no prereqs, right? That's the bottom line. Well, are there prereqs? Well, the only thing is I have to make some assumptions. So, for example, clearly you have to understand English. Clearly you have to be able to write and speak in English. And the other one is you do need a little bit of basic maths. Now, I'm not making a huge assumption here. Basically, I'm assuming that your level of mathematics is at least around year 9, year 10 level when it comes to things like algebra. Look, at the end of the day, chemistry is a science. Part of the language of chemistry is mathematics, and it's important that you be able to use a few mathematical formulae and actually be able to manipulate them in some fashion. So I've got to start from somewhere. If I assumed that you had absolutely no maths whatsoever, then basically I'd never get to teach any chemistry because I'd be running a maths course. So that's my assumption as far as your maths goes and as far as your English language skills go, etc. Okay. Now, the next thing I need you to be aware of is that the students who are coming into this course are very diverse in terms of their academic backgrounds. Now, I've said diverse student body here. It's actually the diversity I'm looking at here isn't sort of ethnic or anything like that. It's basically academic diversity and preparation. So I've got students who are going to be coming into this course who actually have quite an advanced understanding of chemistry. So they may have done, for example, the International Baccalaureate program in chemistry, and so they know quite a bit. Now, if you're one of those people, and I'm talking to you right now, just be aware that whilst I'm going to be covering similar topics to what you've already covered, my approach is going to be very different to probably what you're used to. So just be aware of that, right? I've actually had students come up to me and say, well, why am I doing this course? I've already covered this before in senior chemistry. Well, my answer is, one, hey, I'm not responsible for what enrolment you have to undertake, and two, there's still value in this course even if you think you know a lot of chemistry, because my approach is going to be very different to what you would have normally encountered in high school chemistry. How do I know it's different? Well, at one stage I was actually a high school chemistry teacher, so I do know that. Now, if you are in the other boat, where you're a student who comes in with no chemistry, again, don't panic, because I understand that. As I said before, there's no prerequisites for this course, so just I'm well aware of that. I'm assuming that we're starting off at a very a zero base level in chemistry, basically. Okay, now there's one other thing here that I really want you to be aware of, and it's this dot point here. And that is, this is a university course, which almost seems like a stupid thing to say, considering you know that the course is offered by the university. But what I'm trying to say here is what follows in that dot point. Many students, in my experience, come into first year university in particular, and they bring with them a model of learning and teaching based on high school. And why wouldn't they? Because that's where they've come from. And many of those students have actually been used to the model over 12 years, and they, in many cases, have been very, very successful operating under that model. But this is different. This is a university course, and university courses certainly run differently, and we do have different expectations. Now, we realise that you're bringing a lot of things with you from, say, high school, etc., and so we're not, and I'm not going to drop you right in the deep end here, but you need to be aware that part of my responsibility is getting you used to studying and working in a different environment. So look, what's the difference? Well, the big differences are things like that first one there you can see is independent learning. There's a lot more concentration in universities on giving you the materials and understanding that you need, but then you have to do a lot of that legwork yourself, right? And so you have a level of independence that is much greater than what you would normally expect in high school. If I can put it another way, the difference between high school and university is you are going to become a lot less dependent on your teacher, right? You become a lot more dependent on yourself, and indeed probably more dependent on your colleagues, if anything. So that's the first thing. And you know, at university, no one's going to sit there and make you study, right? You're going to have to do it for yourself, okay? And that is one of the more difficult things that people have trouble getting used to. Okay, so next one is set textbooks. Often in high school, you have a set textbook for a particular course, and you may use that one set textbook for 2 years, if it's year 11 and 12. And you may never look at another textbook. And that's pretty normal, right? And so there's a huge level of dependence you have on that one textbook, and indeed then on your teacher. Now, that's going to change when you're doing university courses. It's not unusual for a university course to have a set textbook, but it's also pretty usual for a university course to assume that you're looking at other textbooks. And this course is exactly like that. In fact, I often say to students, whatever you do, do not rely on one textbook. That is crazy to do that, right? Reason being is textbooks, depending on which one you're reading, will have different, they'll have the same kind of material but different ways of explaining things. And one textbook for one topic might be better than another for you at explaining what's going on. And everyone's a little bit different, so I encourage you must read widely. Do not rely on the set textbook for this course. That's not what we're on about here. Now, I have made that very clear too in the Getting Started section, and when you click on that and you go to the textbook itself and have a look, which I've actually more information about that is actually in Learning Materials in Blackboard. Can't stress enough, look at other and read other textbooks. Okay, what else? So next one's this one about the pace. Look, to be honest with you, if you look at this course and you look at the range of topics I'm covering, it's pretty much similar to what you would expect for year 11 and 12 Chem. I will actually go into a few in a bit more depth, but more or less you could say that the range at least and coverage of material is about the equivalent of, as I said, year 11 or 12 Chem. So, what does this mean? Well, I'm covering that range of material in one semester, right? If you were doing it in high school, you would be covering it in 2 years. That's a huge difference, absolutely huge difference. In other words, the pace is much quicker. Now, you could be sitting here and actually forgiven for thinking that what I should do is be presenting less material, but the amount of material I'm presenting is about what you would expect for a university course in terms of pace. And indeed, this course has been reviewed any number of different times with external and internal reviewers, and all of them are exceedingly happy with the range of material that's being covered. There's never been a mention about a problem with there being too much material in in this course. It's absolutely normal. But in comparison to high school, the pace is much quicker. You could argue that the pace is at least 4 times faster. So why I'm telling you this is because when you approach this course, particularly if you are if you've never done chemistry before, it's really important that you keep on top of it right from the word go. If you let it slide for even a few weeks, you can very quickly get behind to a point where it seems overwhelming. So I can't stress that enough. Keep on top of it. Speaking of keeping on top of it, obviously being a university course, attendance at tutorials and lectures, it's not compulsory for this course. So you don't have to go to any of that stuff. It doesn't mean it's not important, you just don't have to go to it. Now, again, this is very different to high school, right? In high school, the discipline you've got in terms of attending classes and learning is basically external. That is, you're told you got to do it, and there's consequences if you don't do it. In this case, it's put back on you. The discipline is basically, that's required of you, is internal, okay? You have to be the one to make the effort to watch the lectures or go to the lectures or whatever, and also go to the tutorials. Laboratories, by the way, are compulsory. You can look at more details for that in Blackboard, but lectures and tutes aren't, and that's where most of the assessment is going to be based on the material that's presented in lectures. So just be aware of that, and then reinforced and will help you in the tutes. So I can't stress enough, go to the tutorials, make sure you at least watch the online lectures, and but you need to be internally yourself, pushing yourself along to cover that material. And finally, as I've said now quite a few times, it doesn't matter what I say here. At the end of the day, what's most important is what's written in Blackboard. It is so important that you go through and make sure you can understand what's required of you for this course. Okay, now I'm just going to make a few little comments about the topics that I'm covering in this course, and if you haven't done chemistry before, this probably doesn't make a huge amount of sense to you. This slide, I guess, is directed a little bit more at those people who have done some chem before. Now, if you look at these topics here, I think you can see pretty much that they're the kind of topics that you would have covered before in year 11 and 12 chem. Right, so and this actually happened to me in one of the semesters. A student came up to me. This is first lecture, right? Comes up to me and says after the lecture and says, "I don't really need to be here. I've done all this stuff," and this is despite me saying my approach to teaching chemistry is is very different to what you would normally expect in high school. So that's why I'm saying just think about the approach. Now, what is my approach? Okay, so my main approach to teaching this course is I'm going to be focusing on you understanding what's going on, right? Not memorizing. Now, I'm taking the time to explain this to you because I can't stress enough how it's very easy for everyone, including me, to start thinking that remembering something is the same as understanding something. It's better if I just point it out by example. So on the left-hand side there at the top, you can see, let me just get my pen here. A highlighter will do. Okay, I've got this question here. Now, if you've done chem, you know the answer to that. Okay, so the answer, of course, is 6.02 by 10 to the 23. Now, if you're watching this and you've never done chem, don't panic. We will go through this in some detail. As I said, this is more directed at people who've done chemistry before. So, okay, we've got N is... So if I ask you this question, you will, in very, very quickly reply to me and say it's 6.02 by 10 to the 23, right? But what about if I ask you this question? Why is n 6.02 by 10 to the 23? Now, there may indeed be some of you who can answer that. But are there, right? And this highlights the difference between the way I'm going to approach this course and what you would have done previously, right? This is a what question. What is this number? Effectively, what you're doing is answering a question where you can just simply memorize it. This why question is actually asking you a question where memorizing it is simply not enough. I've in fact given you the answer, 6.02 by 10 to the 23. Why is it that particular number? Now, if you can't answer that, I'd say that you'll be learning something in this course, right? Now, I've given you a few other examples. Now, these are just examples. It's not comprehensive, right? But what about this one? What is the oxidation number of sulfur in SO2? So if any of you have done chem, you'll know, right, that there's a bunch of rules for oxidation numbers. So oxygen's 2 minus, therefore sulfur's 4 plus is the oxidation number. And you can apply that rule, okay? But think about what you just did. You applied the rule. But what about if I change the question and I ask you, why are oxidation numbers used, right? What are they actually based on? Did someone just dream this stuff up? You see what I'm saying? Now, I'm not going to go through all of these, but I'm hoping that what you'll do is look at these particular questions here and notice the difference between a what question and a why question. And my focus in this course is why. Right? Now, I'm doing that because I want you to understand some chemistry. Not just memorize it and think you understand it, but actually understand it. And that's what's going to help you for later on. And this is later on. So at the end of the day, I really don't like doing this in a way. This is kind of very corporate, but I decided I'd write myself a mission statement for what I'm actually doing in this course. So here's my mission. My mission is to give you what you need to effectively acquire an understanding of chemistry. Now, let's just pick this apart a little bit here. It's to give you what you need, right? I can't learn it for you, right? I can't really do anything other than give you the tools you need if you want to really effectively learn things, right? And that's why I've written effectively acquire. That's what you need to do, right? So there's a reciprocity here that you simply don't get if you just, going to the shop like Harvey Norman and buying a fridge or something, right? You just hand over the money and that's it. The transaction's done. In this case, there's two parts to this. I can only give you what you need, right? But then you've got to do the acquisition part. You've got to be the one working on your chemistry. You're the one who's actually got to learn it. Now, if I do my job right, and you do your job right, then that should then enable you to learn further into the future. See, my thing is, I'm not just interested in teaching you enough chemistry that you'll stumble through the course, finish the final exam, walk out and never give chemistry another thought again, right? My mission is to give you the tools that you need to then go on and study other courses that actually need some understanding of chemistry. And in fact, I'm ambitious enough to think I can actually give you the tools you need to be able to walk out of this university and keep learning new things based on your understanding of chemistry. And that's what lifelong learning is all about. Anyway, at the end of the day, I can only give you what you need, or at least I can do my best, right? But at the end of the day, to get the complete transaction, I can't do all of that unless you give me some help, right? You actually got to engage with what's going on in this course. Now, I know you probably know that already, but it's just so important that we kick off this course with that mutual understanding. Okay, so I'm going to leave it there. We're then into the actual material for Chapter 1. And I hope that gives you a bit more of an understanding of how I'm approaching this course. And I'm really hoping that at the end of this course, you actually find it quite rewarding, right? That you actually have that understanding that's going to help you with your learning into the future. Okay, I'll leave it there.